Alright, Assalamualaikum warahmatullahi wabarakatuh and good day to everyone. My name is Luqman Nur Hakim bin Orhan and today I'm going to talk about the introduction for the project. Our team has chosen a project that are running in University Tunusin of Malaysia UTSM that located behind the Faculty of Civil Engineering building, or we all know as FCAP, and the project purpose is to upgrade the facilities of students, connecting all the faculty around it into the central of cafeteria and student affairs office at University Tunusin of Malaysia. In today's presentation, we are going to be more focused on the excavation works, which we know excavation works involve digging trenches and or holes in the ground. It is a high risk activity that requires proper safety precautions. And we can see the main hazard in excavation include cave-ins, falls, falling loads, and a lot of hazardous atmosphere. For example, improper storage of construction materials. So our group will bring you all to explore all the risk assessment, all the hazard that we can talk from the chosen construction site that our group have chose in order to ensure the workplace safety and compliance with the Osha requirement and Malaysian standards. So hope you all enjoy.
Now my part is overview of construction site. We visited a construction site to improve drainage around the Student Affairs Office, which is HEP, and the cafeteria at UTHM because when it rains, the water often stagnates. Excavation works using heavy machinery can pose safety risks such as falling debris and collisions between machinery and laborers due to carelessness. To address this risk, a risk assessment is recommended. This assessment will identify hazards such as missing signage or improper storage of materials, and suggest control measures such as clear warning sign or designated storage areas. By doing this, the project can significantly improve safety for everyone around the site. Thank you.
So we go for the part, the identification potential hazards at the site. We choose the excavation work, which is crucial in the context of construction and civil engineering for several important reasons. First, excavation involves digging into the ground to create foundations for concrete drains. Proper excavation ensures the stability and strength of these structures. Second, soil removal is the process of transporting the excavated soil to designated disposal area to maintain a clean and stable work site. As we can see in the first figure, where the workers performing excavation work without glove. For this, there was physical injuries to hands, where rough or rocky soil can result in the cuts, scrapes, or abrasions on the hands of workers. Next, in the second figure, where the irregular excavation work that caused Charles' death. The potential hazard is exposure to the hazardous materials. Workers may be exposed to hazardous chemicals or biological materials hidden in the irregular soil formations. For the third figure, where the excavation work without using safety helmet and high worker density, the potential hazard is physical injuries and accident, also safety disruption, where the workers may suffer physical injuries such as slipping, falling, or getting hurt due to the uneven or rocky terrain. High worker density in one area can hinder visibility and movement, increasing the risk of accidents such as tripping, falling, or being struck by heavy equipment. Next, the method of risk assessment. For the risk estimation, focuses on assessing the likelihood and severity or identify risk, where the likelihood is referred to the probability or frequency of a risk event occurring. Likelihood can be assessed qualitatively or quantitatively. Severity is evaluates the potential impact of consequence if a risk event were to occur. It ranges from minor impact to catastrophic figures. For the risk evaluation, It was the integrates the estimated likelihood and severity to determine the overall risk level using a risk matrix. Risk matrix is a visual tool that categorizes risk based on their assessed likelihood and severity. It typically consists of a grid with likelihood on one axis, which is horizontal, and severity on the other axis, which is vertical. The intersection of these axes creates cells that represent different risk level.
Hi, Assalamualaikum and a very good evening to Dr. Shushilawati. I am Nur Nadia Izzati binti Zamri, CF210212, and I'm going to continue this presentation with control measure for the potential hazard. So here are the 10 potential hazard that I have listed on the slide for construction site at landscape planning at Cafe HCP, including at least 3 health hazard. So there is 10 hazard that I have listed, which is where the condition, uneven surface, scattered and excavation rocks, dust and airborne particles, material, posture, heavy machinery, and also trench collapse. So I'm going to continue with the next slide. So the first potential hazard that I have listed on for this project is trench collapse. So actually the excavation works can lead to trench collapsing, posing a serious risk to workers inside, because at the site construction that we listed on for this project, there's a lot of trees, and maybe it can be collapsing for the trees and also the trench. So it is risking for workers for the construction site. And the second one is heavy machinery accidents. So at the construction site, they use backhoes as the heavy machinery. So there will be a potential hazard, which is heavy machinery accidents, because the use of heavy equipment such as bulldozers, excavators, and backhoes can lead to accidents if not properly handled by the workers. Okay, the third one is posture. Posture is related to the workers' posture, which is bend posture that lead to musculoskeletal strain, back pain, reduced mobility, and also long-term health issue affecting overall comfort and also productivity. The fourth one is material like brick, cement, and aggregate also can have the potential hazards. Okay, so for the third slide, which is I will continue with the potential hazard. For the fifth one, which is hose and equipment, unevenly placed hose or other tools, including tripping hazards, potential injuries from sharp edge, work on area obstruction, equipment damage, and also risk to both workers and bystanders. So the sixth one is dust and airborne particles, which include the hazard, which is excavation can release dust and other particles into the air, causing respiratory problems for the workers. For the next one, the seventh one is scattered excavation rocks, including tripping and falling, equipment damage, obstruction of work areas, risk of rolling and shifting, and also potential injury by workers and bystanders. The eighth one is uneven surface, like debris or material lying down around the site can cause slips or maybe trips and fall. So it is potential hazard that can be dangerous to the workers. Okay, the ninth one is about weather condition can be the potential hazards at construction site, because adverse weather such as rain or extreme heat can create hazardous working conditions, including slippery surface or heat stroke. And the last one is uncovered drain that we look at the construction site, which is it can pose hazards such as tripping and falling, vehicle damage, and also water contamination. And other than that, it can be hazard and risk by blockage or accidental entry by small children and animals. Okay, for the last one, I will be present about engineering control to eliminate hazards identified through hazard guideline, which is the first one is weather conditions. So the engineering control is installation of weather shelter or enclosures for outdoor work areas to protect workers from rain, wind or extreme temperature. And the second one is uneven surfaces. We can be controlled by grading and leveling of work using heavy machinery and equipment to create a smooth and stable surface. The third one is scattered excavation works. We can implement of mechanized sorting and handling system to automate rock placement and reduce manual handling risks. The fourth one is dust and airborne particles. We can install and use the local exhaust ventilation system or dust suppression equipment such as water sprays to capture and control airborne particles at the source. And then the fifth one is holes and equipment. We can establish and organize tool storage areas with design racks or toolbox to ensure tools are safely stored and readily accessible. The next hazard is material. So engineering control for material is adoption of automated conveyor system or material handling equipment to ensure control and even distribution of materials, minimizing risks associated with manual handling and uneven placement. And the number 8 is posture. So engineering control for posture is design and provision an ergonomic workstation and tools to provide or promote the proper posture and reduce strain to the body. This may include adjustable workbench or ergonomic chairs. And the ninth one is implement heavy machinery accidents. So we can implement of proximity detection system, safety interlocks and backup alarms on heavy machinery to enhance the operator awareness and prevent collision. And the last one is trench collapse. The engineering control for trench collapse is installation of trench box or shoring system to stabilize trench wall and prevent collapse during excavation works. That's all from me. Thank you. I will be passed to the next presenter. Thank you.
Hi, my name is Nur Amirahani binti Muhammad Yusof. My matrix number CF230049. Okay, so today I will start with determination of the most critical hazard, which is trench collapses. Okay, so as we know, university construction projects pose a significant threat to workers due to the potential of catastrophic consequences such as trench collapses. These collapses can result in suffocation, severe injuries, and long-term disabilities. The diverse workforce, including student workers, temporary labourers, and those with limited construction experience, heighten the risk of collapse. Pre-existing underground infrastructure such as the utility lines, historical buildings and landscaping features can introduce unforeseen complications during excavation. The presence of students, faculty and visitors on campus necessitates stricter safety protocols. The consequences of trench collapse extend beyond workers' injuries or fatalities. Universities, as a public trust institution, face significant damage to their reputation following construction accidents. Public outrage, negative press coverage, and legal consequences can pressure universities to prioritize safety and implement stringent measures. Finally, the financial aftermath of the trench collapse can deplete educational institutions' resources, leading to compensation claims, penalties, and lawsuits. Therefore, universities must prioritize trench safety to prevent costly setbacks and maintain their reputation. Okay, for the discussion number 2, trench collapse can pose a significant threat to the construction industry, necessitating robust safety measures that align with engineering standards and regulatory requirements. These measures include proper shoring and shielding, sloping and benching techniques, soil analysis, safe entry and exit points, regular inspection and monitoring, and comprehensive worker training. Okay, for shoring and shielding, it involves the installation of support structure and trench boxes. This means to prevent soil movement and safeguard workers from the potential cave-ins. Despite the significant upfront cost, their widespread acceptance and availability of rental options make them financially viable. Sloping and benching techniques, on the other hand, offer less expensive alternatives but may result in increased excavation volume and cost. Next, which is regular soil analysis. This is crucial to determining the type and stability of soil, guiding the selection of appropriate protective measure. Investing in comprehensive worker training programs on trench safety helps to reduce accident rates and ensure compliance with safety regulation. Last but not least, in achieving a balance between safety and economic limitations, it requires efficient resource of allocation and project management strategies. Allocating financial resource towards during the initial stage of project planning and promoting interdisciplinary collaboration can help in identifying opportunities to save costs and ensure optimal utilization of resource. Implementing lean construction practice a real-time monitoring system and can enhance safety measure efficiency and contribute to the overall success and sustainability of the project.